Good morning, students. So today we are discussing that is the lenses in contact. So two thin lenses in contact. What is the focal length and the power formula we are discussing? So for that we are considering the two thin lenses in contact with each other. Here you can see. So this is the first lens and this is the second lens. Then this is the principal axis of that. Okay, then next. Here, this is L1. The lens is named as L1 and this is the lens L2 here. And here on the principal axis, we are keeping the object O. This is the incident ray and the refracted ray. So here the two images we can see due to first lens and due to the second lens. Okay, so this one you can name it as I1 and this one you can name it as I. So this is the object image distance is V and this image distance is taken as V1 and here is the object distance that is named as U. Okay, so now very simple derivation actually it is. Here what we are doing, we are considering the two thin lenses L1 and L2 in contact with each other whose focal length is taken as F1 and F2 where O be the object on the principal axis at a distance of U and V be the image distance. V1 is also the image distance. Okay, so here we have the derivation. We will start it. The equation 1 is very, very important. That is we are using, that is 1 by F is equal to, that is length formula C. 1 by U plus 1 by V. Okay, we are using the lens formula. With the help of the lens formula, we are proceeding the steps here. So the lens formula, it is given by 1 by F minus will come, not plus here, minus is there. That is the image distance. So here we will take the lens formula. The lens formula is given by, it is 1 by F is equal to 1 by the image distance. So the image distance is V plus the object distance is what? That is, sorry, minus the object distance is U. This is our equation 1. Okay. So now refraction at the lens L1 in the absence of L2. So first what we are doing? So imagine second lens illa anta imagine madi. Whatever L2 is there, adilla anta andaga. L1 is the lens. The image is formed at I1. Gotakta students. So here L1 is the lens. Here the object is placed at O. So due to this object, the image is formed at I1. The image is formed at I1. So therefore, the focal length is what? F1 anta ide or image distance V1 anta agate and the object distance is that is U. So therefore, the equation is now written as, so first step, the image formation, the refraction at lens L1, the refraction at lens L1 in absence of L2. In absence of L2 we are seeing here. Okay. So therefore now here it is written as the focal length is F1. 1 by F1 is equal to 1 by V1 minus 1 upon U. This is our equation 2. This is our equation 2. Okay. Next, so the second step what we are doing, the second step is the refraction at the lens L2 we are seeing. So L2 lens ಗೆ refraction ನೋಡ್ತಾ ಇದೀವಿ for the L2 lens. So that time the focal length is written as 1 by F2 which is equal to the image distance is ಈಗ V is the image distance minus here object distance enagatte V1 is the object distance. So this is our equation 3. Okay. So I'll repeat what is equation 2 and 3 here, students. So here we are considering the two thin lenses, but we are seeing the derivation in 2 steps. So 2 steps alli ನಾವು ಏನೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತ ಅಂದ್ರೆ here first we are considering that is the first lens L1. So L1 lens consider ಮಾಡ್ತೀರಾ, that is the object, O is the object, and here the image is formed at what? The image is formed at I1. The image is formed at I1. So this I1 is at a distance of what? That is V1. Okay. So next what we are going to do? Next we are considering the second lens L2. So L2 lens consider ಮಾಡಿದಾಗ I1 ನಿಮ್ದು object ಆಗಿ act ಮಾಡುತ್ತೆ. I1 acts as the object and the image is formed at I. ಹಾಗಾದ್ರೆ object distance ಏನಾಯ್ತು? V1 ಆಯ್ತು. And the image distance is nothing but it is V. So that is your equation 2 and 3. If any doubt is there with respect to equation 2 and 3, please ask. Equation 1 is the lens formula. So 2 and 3, we are writing it based on the equation 1. If any doubt is there, please ask for the equation 2 and 3. Okay. So if there is no doubt in equation 2 and 3, what I can do is that is adding equation 2 and 3. So now what we are doing? 2 plus 3. So adding equation 2 and 3, what we will get? C. That is 1 by F1 plus 1 by F2 is equal to, it is 1 by V1 minus 1 by U plus 1 by V minus 1 by V1. Yes. So now if you see the equation here, the common terms will get cancelled. So what are the common terms here? 1 by V1 and 1 by V1 will get cancelled. So what is remaining here, students? So the remaining is 1 by V minus 1 upon U. This is 1 upon F1 plus 1 upon F2. So this is 1 upon F1 plus 1 upon F2. So suppose if the two thin lenses are replaced by one single lens, now if I compare equation 1 and equation, now name this equation as equation 4. Name this equation as equation 1 and 4. Suppose if we replace the two thin lenses by one lens which is having the same effect, now ಅವಾಗ ಯಾವ ರೀತಿಯಾಗಿ ಬರಿಬಹುದು? 1 by F is written as 1 by V minus 1 by U, equation 5. So ನಾವು ಏನ್ ಹೇಳ್ತಾ ಇದ್ದೀವಿ? So lens L1 is having the focal length F1, lens L2 is having the focal length F2. So ಇದು ಎರಡನ್ನು replace ಮಾಡಿ if you are taking one lens whose focal length is F. ಆಯ್ತಾ? So the equation I am writing it as what? Andre 1 by F1 plus 1 by F2 is taken as 1 by F, which is equal to 1 by V minus 1 upon U. Okay. So therefore, now if we compare the equation 5 and equation 1, equation 5 ಮತ್ತೆ equation 1 and compare ಮಾಡಿದ್ರೆ ಏನಂತ ಬರಿಬಹುದು students? We can write it as 1 by F is equal to 1 by F1 plus 1 upon F2. 1 by F1 plus 1 upon F2 is equal to 1 upon F. This is the equivalent focal length when two focal lengths are kept in contact with each other. Okay. So this is the equivalent focal length when two thin lenses are kept in contact with each other. So the reciprocal of focal length is called as what? It is the power. So therefore power P is equal to, it is written as 1 upon, P1 plus P2. This is for the power. Yes. So if any doubt is there in the derivation, you are free to ask. So that ಅಷ್ಟೇನ್ ಜಾಸ್ತಿ ಇಂಪಾರ್ಟೆಂಟ್ ಇಲ್ಲ, just for your understanding if you do also it's fine. ಬಂದ್ರೆ 2 marks 3 marks ಬಂದ್ರೆ ಬರುತ್ತೆ, but rarely it will come. Okay. So just remember the equivalent focal length and equivalent power is P is equal to P1 plus P2. 2 lenses. ಸೊ ಅದೇ ರೀತಿಯಾಗಿ n ಟರ್ಮ್ಸ್ ಕೂಡ ನಾವು ಇದನ್ನ ಕಂಟಿನ್ಯೂ ಮಾಡಬಹುದು, ಮೀನ್ಸ್ ಅಪ್ ಟು n ಟರ್ಮ್ಸ್, n lenses, n number of lenses. Okay, so let us go for the next point, students. Okay, so let us go for the next concept. So next we are discussing, students, that is the human eye. Okay, so in the human eye, some of the defects we are discussing. Yes, so before going to discuss the defects, we'll see some of the terms related to the human eye. So already in biology, we'll study this. So just for your remembrance, we will recall the points. Okay, so if you see the eye here, you might be knowing that is where the images are formed in the eye, students. Any idea is there? Image L form agate. So in your eye, where the images are formed, or on what part the images are formed here? Which part? See here, the images are formed on the retina. You might have heard the word. So the images are formed on the retina. Okay. So we have the different parts here in the eye. That is, we have the eye lens. We have the retina anta ide, eye lens irutte. Then muscles, different muscles we have. Then next cornea is there, pupil is there. Yes. Then optic nerve is there, ciliary muscles are there, iris is there. So different parts we have in the eye. Okay, so these parts are having different works. So here on the retina, andre retina ಅನ್ನೋದು ಏನಿರುತ್ತೆ, it acts like a screen. So if you consider this as roughly ನೀವು ಇದನ್ನ eye ಅಂತ consider ಮಾಡಿದ್ರೆ, this is the front part, this is the back side part. So back side part ಅಲ್ಲಿ ಏನೊಂದು screen ತರ structure ಇರುತ್ತೆ, that is called as the retina. So the images are formed on the retina here. It is connected to the optic nerve. So ಅವಾಗ ಏನಾಗುತ್ತೆ, ಬ್ರೈನಿಗೆ ಸಿಗ್ನಲ್ ಹೋಗುತ್ತೆ and it will detect and then the signals will come back here. So this is how the optic nerve and the retina works. ಅದೇ ರೀತಿಯಾಗಿ ciliary muscles ಅಂತ ಇದೆ, students. In eye we have the ciliary muscles. So what the ciliary muscles will do, the ciliary muscles, they are helping to contract and to relax the whatever the nerves are there here. Okay, so the ciliary muscles will adjust the focal length anta helbodu. It will adjust the focal length. So ನಿಮಗೆ ಗೊತ್ತಿರಬಹುದು, ಸಪೋಸ್ ನೀವೀಗ ಮನೆ ಒಳಗಡೆ ಇರ್ತೀರಾ. ಸೊ ನಾವು ಇಟ್ ಇಸ್ ಅ ಸಮ್ಮರ್, ಸಪೋಸ್ ಇಫ್ ಯು ಗೋ ಔಟ್ ಆಫ್ ದ ಹೋಮ್, ಅವಾಗ ಏನಾಗತ್ತೆ ಅಂತ ಅಂದ್ರೆ, ದೇರ್ ಸಪೋಸ್ ಇಫ್ ಇಟ್ ಇಸ್ ಸನ್ನಿ ಡೇ, ಅಂದ್ರೆ ಏನ್ ಬಿಸಿಲಿರತ್ತೆ, ನೀವು ಹೊರಗಡೆ ಸಡನ್ ಆಗಿ ಬಂದಾಗ your eye will take fraction of time to adjust that whatever the change in the light intensity is there. Similarly, ಬಿಸಿಲಲ್ಲಿ ನಿಂತ್ಕೊಂಡು ಒಳಗಡೆ ನೀವು ಮನೆ ಒಳಗಡೆ ಎಂಟರ್ ಆದಾಗ ಕೂಡ ಸೇಮ್. So for a fraction of time, you are not able to see the things properly. Then after some time, you are able to see the things properly, right? ಅದೇ ರೀತಿಯಾಗಿ ಏನಾಗುತ್ತೆ, suppose if you are entering the theater. So ನೀವೇನಾದ್ರೂ theater ಗೆ ಹೋದಾಗ, so it is a dark room, right? So initially ನಿಮ್ಗೆ ಏನು ಸಡನ್ ಆಗಿ ಹೋದ್ ಕೂಡಲೇ ಕಾಣಿಸಲ್ಲ. So suppose if you wait some time, after that you are able to at least see whatever the things are there around in that small lights. Okay, so ಆ ರೀತಿಯಾಗಿ focal length of the eye is adjusted by the, that is retina, ciliary muscles adjust ಮಾಡುತ್ತೆ. So this phenomena ನಾವೀಗೇನ್ ಹೇಳಿದ್ವಿ, that is the adjustment of the focal length, that is called as accommodation power, that is called as accommodating or the accommodation power. What is accommodation power? It is the ability of the eye lens due to which it change its curvature and hence the focal length to see the objects clearly situated at different distances. So ಇದೇನ್ ಮಾಡತ್ತೆ ಅಂತಂದ್ರೆ, eye lens will adjust, it will adjust the curvature, it will adjust the curvature, and hence the focal length of the eye lens is adjusted so to see the things around it at different places or the different distances. That is called as what? Accommodation of the eye. Okay, so what is the least and the least distinct vision, or then the far distinct vision? Yargaru gottidya? What is the least and the far distinct vision? ಅಂದ್ರೆ ಮಿನಿಮಮ್ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ವರೆಗೂ ನೀವೇನಾದ್ರೂ ಆಬ್ಜೆಕ್ಟ್ ಇದ್ರೆ ನೋಡ್ಬೋದು, ಅಂಡ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ವರೆಗೂ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಇದ್ರೆ ನೋಡ್ಬೋದು. ಎನಿ ಐಡಿಯಾ? See, maximum is up to infinite distance, that is up to, yes, 25 centimeter, correct? So minimum distance ಅಂದ್ರೆ least distance clearly ನೀವು ನೋಡ್ಬೇಕ ಆಗೋದು, that is 25 centimeter. ಅಂದ್ರೆ suppose if you are holding a book in front of your eyes, ಆವಾಗ you just take it closer and closer. So ನಿಮ್ ಹತ್ರ ತಗೊಳ್ತಾ ಹೋದಾಗ ಒಂದ್ ಪಾಯಿಂಟಿಗೆ ನೀವು ಅದನ್ನ ಕ್ರಾಸ್ ಮಾಡಿದ್ರಿ ಅಂತಂದ್ರೆ you are not able to see those things clearly, right? So ಅದೇನ ಪಾಯಿಂಟ್ ಇರುತ್ತೆ, that is for the normal person ಅದು 25 centimeter distance ವರೆಗೂ. ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಆದ್ರೆ ಬ್ಲರ್ ಆಗಿ ಕಾಣಿಸ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. And the maximum distance up to which you can see is, that is the infinite distance, that is up to infinite distance. Okay, so this is regarding the accommodation power and the least and the far point. Now we are discussing with some of the defects. So for that, I'll show you some figures. Okay, 1 second, I'll share that. Yes, here you can see students, that is the structure of the eye. Okay, the different parts you can see. So here the labeling is there, 1 2 3 number ಇದೆ ಕೆಳಗಡೆ ಅದರದ್ದು parts ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಬಹುದು ನೀವು ಇಲ್ಲಿ. So 1 is referred as the optic nerve, ಇಲ್ಲಿ back side ಅಲ್ಲಿ ನೋಡಿ, that is 2 is referred as the optic disc, 3 is for the centrals, that is 4th is for the retina, 5th is for the sclera, then 6th is choroid, then 7 is ciliary muscles, you can see where the ciliary muscles are there, then 8th is the lenses, 9 cornea, then 10th is the pupil, 11th part is that is aqueous body, the 12th one is for the iris, the 13th is that is suspensory ligament, 14th is the vitreous body. So these are the different parts of the body. So biology ಜಾಸ್ತಿ ನೀವು detail ಅಲ್ಲಿ ಕಲಿತೀರಾ. So ನಮ್ಗೆ ಇಲ್ಲಿ ಮೇನು ciliary muscles, the eye lens and the that is the retina. Okay, so now we are discussing some of the defects of the eye here, students. The first one is that is the myopia we are discussing. Okay, this is the first defect we are discussing, myopia. So what is myopia here? You can see. So where what is first figure ನೀವು ಏನು ನೋಡ್ತಾ ಇದ್ದೀರಾ? The first figure is for the normal eye. ನೀವು in first figure ಏನು observe ಮಾಡ್ತಾ ಇದ್ದೀರಾ? This is for the normal eye. Here the object is there. ಇಲ್ಲಿ object ಇದೆ. Then from the object, the light radiations are coming. It is meeting after the eye lens, after refraction, it is meeting at the retina. This is for the normal eye. Okay. So next what you are seeing the second figure. The second figure is that is here the images are not formed on the retina. Here the images are formed. ಇಲ್ಲಿ ನೋಡಬಹುದು light rays ಎಲ್ಲಿ meet ಆಗತ್ತೆ ಅಲ್ಲಿ image form ಆಗತ್ತೆ ಅಂತ ನಾವು ಕಲ್ತಿದೀವಿ. So in previous case ಅಲ್ಲಿ on the retina it is meeting, therefore the images are formed on the retina. But in the second figure ನೀವೇನ್ ನೋಡ್ತಾ ಇದ್ದೀರಾ, that is the light rays are meeting in front of the retina, right? So therefore here this condition is called as what? Myopic condition. This condition is called as myopic condition. So what do you mean by the myopic condition? The rays will not meet on the retina. It will meet in front of the retina. So this type of defect is called as what? Myopic eye. Okay. So here in this case, the people are not able to see the far objects clearly. So ದೂರ ಇರುವಂತ objects ಅನ್ನ clearly ನೋಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. That kind of condition is called as what? Myopic eye. So after that what happens here for the myopic person, here what you can do, ಅದನ್ನ ಕರೆಕ್ಟ್ ಮಾಡ್ಬೇಕು ಅಂತ ಅಂದ್ರೆ it is not any big defect ಆಯ್ತಾ. So ನೀವು ಇದನ್ನ ಕರೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಬಹುದು by using ಈ ಫಿಗರ್ ಅಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ದೀರಾ ನೋಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಥರ್ಡ್ ಫಿಗರ್ ಅಲ್ಲಿ ಯಾವ ಲೆನ್ಸ್ ಇದು? Which type of lens it is? Yes, tell me. So if you use that lens, the images will form on the retina. So this is myopic condition. Concave lens. Correct? Yes. So it is a concave lens. So here the images are formed. After using the concave lens, the image will form on the retina. Okay. So what is myopic condition? Hope so you understood. So usually the images are formed on the retina. Myopic condition iddaga the images will not form on the retina. It will form in front of the retina. Okay. Then after that here what happens when you use a concave lens, the image will properly form on the retina. And here in this case, the people are not able to see the far objects clearly. ಆಯ್ತಾ? ಸೊ ದ ಮಯೋಫಿಕ್ ಅಥವಾ ಮಯೋಫಿಯಾ ಅಂತ ಹೇಳ್ತಾರೆ. ಈ ಡಿಫೆಕ್ಟ್ ಗೆ ಮಯೋಫಿಯಾ ಅಂತ ಹೇಳ್ತೀವಿ. And it is also called as what? That is nearsightedness. It is also called as what? Nearsightedness. Okay, let us go for the next point. Hope so it is clear to you. The next one, that is the hypermetrophic condition. So this is also called as far-sightedness. ಇದನ್ನ far-sightedness ಅಂತ ಹೇಳ್ತಾರೆ. So you can see, ನೀವು first ಅರ್ಥ ಆಗಿದೆ, you can only understand the second one. See, observe the figures. Yes, here what happens, that is the images. First figure, normal it is. Second figure, you can see in images are not formed on the retina. It is forming backside of the retina. ಹೌದಾ? Yes, and this case, the near objects cannot be seen clearly. And this condition is called as nearsightedness or hypermetropia. And to correct this, we are using the convex lens. We are using the convex lens. Yes, if you want, just you can take a screenshot of this figure, this one and the myopia. So very simple. Okay. The next, that is astigmatism. So next defect we are discussing, that is astigmatism. Presbyopia is there. So see what is presbyopia. So this is it is the hypermetrophic of the elderly person. So ಇಲ್ಲಿ ನಾವು presbyopia ನೋಡ್ತಿರ್ವಿ, it is due to the aging it occurs. So here you can see this is an age related condition caused due to the weakening of the ciliary muscles, hardening of the lens and reduced lens flexibility. So here due to the aging, here what happens, that is it is caused due to the weakening of the ciliary muscles, hardening of the lens and reduced lens flexibility. A person with this defect usually finds difficulties focusing on nearby objects and is unable to read or write. So you can see due to the aging, the people will start using the specs here. That is because of the these all conditions. ಏನಾಗತ್ತೆ ಅಂತಂದ್ರೆ the ciliary muscles weak ಆಗತ್ತೆ, the lenses will become hard and the reduced lens flexibility. This defects occurs, that is called as the presbyopia. Okay, so this is regarding the presbyopia. The presbyopia can be corrected by using the convex lens here, students. Okay, so presbyopia na ನಾವು convex lens use ಮಾಡಿ correct ಮಾಡಬಹುದು. Then cataract, you might have heard about the cataract surgery. See, this is again the age-related condition caused due to the loss of transparency of the lens by erosion of lens proteins. It usually results in the blurry vision, cloudy lenses, and can be corrected by replacing an old lens with an artificial lenses. So cataract surgery anta ಮಾಡ್ತಾರೆ. You might have heard these conditions. This is called as what? Presbyopia, cataract condition, hypermetropia, and the myopia. Okay. One more is there, that is the astigmatism anta. So what is astigmatism condition? See. Astigmatism. So in the astigmatism, it is a vision defect due to which a person cannot simultaneously both horizontal and the vertical views of an object with the same clarity. So astigmatism, it is a different type of defect anta ಹೇಳ್ಬೋದು. So these are the horizontal lines and these are the vertical lines. So vertical lines, horizontal lines, ಈ ತರ ಏನಾದ್ರು structure ಇದ್ರೆ the people are not able to see both the lines here. ಕೆಲವೊಬ್ಬರಿಗೆ ಬರೀ vertical lines ಕಾಣುತ್ತೆ, ಕೆಲವರಿಗೆ ಬರೀ horizontal lines ಕಾಣುತ್ತೆ clear ಆಗಿ. So both the lines clearly they are not able to see. This type of condition is called as what? Astigmatism. Okay, so to correct the astigmatism, it is corrected by using a cylindrical cell. So astigmatism anna cylindrical cells ಅನ್ನು use ಮಾಡಿ correct ಮಾಡ್ತಾರೆ. Okay, cylindrical cells of suitable radius of curvature between the eye and the object. Yes, so this is regarding one more defect, that is the astigmatism. Yes, so till here, any doubt is there? Please ask. So different defects we have discussed, the lenses in contact we have discussed. The last part we have the microscope and the telescope working. So if any doubt is there in up to this point, you can ask. The last part it is remaining, that is the telescope and the microscope. In that its resolving power part is deleted. So only we need to go through the diagram and the image formation, which is very, very important. So that we are discussing tomorrow. Okay. So that we will discuss tomorrow. So today just we will discuss some of the questions now related to the ray optics, which we have completed till now. Okay. So MCQs we will see. Yes, here you will see some questions. So you can tell me in the chat box the answers. Yes, the first question here, students. The speed of light in vacuum is 3 into 10 is to 5, 3 into 10 is to 5 kilometer per second, 3 into 10 is to 8 kilometer per second, 3 into 10 is to 6 meter per second. Yes, the speed of light in vacuum is 3 into 10 is to 8 meter per second, or you can take it as 3 into 10 is to 5 kilometer per second. So meter per second ಅಲ್ಲಿ 3 into 10 is to 8 ಆಗತ್ತೆ, but it is not given as meter per second in 10 is to 8. So ಹಾಗಾಗಿ option B ಹೋಗೋಣ, that is 3 into 10 is to 5 kilometer per second. Option B is the correct answer. See the second question, students. What is the relation between focal length and the radius of curvature of a mirror? Yes, what is the relation between focal length and radius of curvature? F is equal to R by 2, yeah, R is equal to F by 2, R is equal to F, or R is equal to F by 3. Yes, that is R is equal to option A. F is equal to R by 2. Yes, correct answer. So second question, R by 2 is correct. Go for this third question, students. The position of the object to get the virtual image in case of the concave mirror is. Yes, so it is option D. Here at all the concave mirror ಅಲ್ಲಿ ಎಲ್ಲ position ಗೆ, sorry, option A. In case of the concave mirror, for all the cases, it will be a real image. Only one case is there where we will get the virtual image. That is option A, between F and the P. So focus ಮತ್ತೆ pole madhyadallittaga, we will get the virtual image. That is option A is the right answer for the third question. See the next question. Yes. For the concave mirror produces magnification equal to -1, option B. Yes, option B. Go for the next question. The mirror which produces only a virtual and diminished images. The mirror which produces virtual and diminished image, that is mirror which produces virtual image is. So here the convex mirrors will produce the virtual image. That is option C. Yes, very good. Option C is the correct answer. Go for the next question. The bouncing back of light after hitting any surface is called as what? It is interference, refraction, reflection, diffraction. So here, this is nothing but the reflection. Option D is the D option, that is bouncing back of light in the same medium. Mala. After hitting the surface, it is reflection. Option D is the right answer. Yes. So the next question, 7. For what angle of incidence Snell's law is not valid? Yes, that is option B here, students. That is for the zero angle. Okay. So that is 0 degree. What is the angle of incidence for which Snell's law is not valid? That is the 0 degree. The next question, the color of light which has the highest refractive index. The color of light which has the highest refractive index. It is option A, that is violet. Option A. Yes, option A, violet is the last question correct answer. Next, question number 9, the color which has the least refractive index. That is red. Option B is the correct answer. Yes. Last question. After this, we will stop. Due to the atmospheric refraction of the sunlight, the length of the day increases by about. Actually, this is there in the 10th class that it increases by 2 minutes. Okay. So some general questions are also there in this. So you can take option A, that is 2 minutes. Okay. So we will continue in the next class, students, with the last part of the chapter, microscope and the telescope. So thank you. Bye.